So we'll be discussing the experiments related to the CogVLM. So in order to validate its performance and generalization of the base model of the CogVLM, right? So they have kind of done a quantitative analysis across the several multimodal benchmarks. So basically, these benchmarks are categorized into various categories, like image captioning, benchmarking, as well as on VQA task as well. And in order to test the advanced capabilities of the large multimodals, right? So they have, like quantitatively, they have evaluated across multiple large vision language model benchmarks. Similarly, on the visual grounding task as well. So these are the various benchmarking tasks they have considered in order to establish or analyze the base model performance related to the CogVLM. Okay. So when it comes to image captioning, right? In order to benchmark it on image captioning, so they have considered various data sets like NoCaps, COCO, Flickr 30K, and TextCap. So basically, image captioning, as I mentioned, it's all about the textual description of the visual content present in the image, right? So that is another one is the VQA. In order to test and validate the how it is performing on VQA task, right? They have considered various data sets such as VQA V2, OK VQA, Text VQA, OCR VQA, and Science QA. So these are the various standard data sets one need to evaluate in order to test how the proposed model is performing comparison to other SOTA architectures. So when it comes to LVLM, so there are it's like there are various data sets like MMWeight, MMBench, Seedbench, LavaBench, Pope, MMMU, MathVista. So basically the task LVLM benchmarks, right? The tasks such as object recognition and localization, OCR, visual description, and visual knowledge. These are very advanced capabilities of the multimodals in addition to a VQA and image caption. So another different task which is not involved in AVM, right? That is a visual grounding task. So it's like basically the reference links between the textual descriptions and the specific regions in the image. So the descriptions are not pointing to the whole image; it is pointing to a certain regions in the image. So the data sets used for visual grounding benchmarks, right? Visual 7W, RefCoco, RefCoco Plus, RefCoco G to ensure the completeness. So when it comes to image captioning, right? So zero shot evaluation is done on the low caps and Flickr data sets to measure a precision in describing the long tail visual concepts. And results from fine tuning on COCO and TextCap data sets. So the detailed performance is shown in the table one, which will come in the next slide. So we'll discuss more over there as well. So they have shown that CogVLM achieves SOTA performance or comparable performance across all benchmarks. So when it comes to caps, as well as I will show in the slides, right, which are going to come. So the base model outperforms the previous best method, KIT2, across four speeds. So the maximum improvement is 5.7 points in the score in the out of domain, while using only 10% of the training data. That is 1.5 billion tokens are used in pre-training data as opposed to 12.9 billion, which was used in the Git2 training. So, and Flickr benchmark. So when it comes to Flickr benchmarks, the previous best was CanVL. That's what they claim. So now it is achieved SOTA score of 94.9, which surpasses the previous best by 9.1 points. So when it comes to COCO and TextCaps evaluations, right? So the base model demonstrates a very significant text reading ability despite training without dedicated OCR dataset. That is, the previous best was the 55 billion, and it outperforms the previous best of the same scale, Poly 17 by 9.1 points, as well as when it comes to 55B, it is on par with that one, right? That's why it is said to be a competitive performance. So these are the benchmarks like on low caps and Flickr and Coco and Text caps, right? So if you see on the no caps, right? So if you see 132.6 and 128.3 are the CogVLM scores, the previous best was Git2. So the amount of training data is 12.9 billion tokens, whereas the CogVLM is 1.5 billion. So there is a very less amount of training data, but significantly outperforms the previous best. So when it comes to Flickr, so 94.9, the previous best was a CogVL. So when it comes to Coco and text caps, so it is like if you look at the Poly 55B, right, it is the best, but it is a 55 billion parameter model, whereas the CogVL is 17. So it is almost comparable to it. So close to it, right? But when it comes to 17B Poly, right, which are of same scale in this number of parameter, right? So it's on par with it, right? 144, 148, but yeah, it's like almost 148.7 and 149.1. Whereas in text caps, it is superior to that same scale. Whereas when it comes to Coco, it is on par with it. So that those are the observations from that work. So when it comes to VQA experiments, right? So there are say like the type of data sets they have considered in the VQA benchmarking, right? There are VQA V2, which is the daily life image questioning answering data set, whereas text VQA and OCR VQA are the text intensive image questioning answering data sets, whereas OK VQA and Science QA are the knowledge demanding data sets. So the model has shown generalization capabilities and potential across all these diverse domains. So yeah, that's what this. So that you can observe from this table as well on VQRI. So on most of the benchmarks, OK, VQA, and all for OK, text and OCR and science, this is kind of a superior. When it comes to VQA, V2, it is close to the previous best. That is emu to chat. Okay. So next one is LVLM benchmarking, right? So different capabilities. Huh. So if you look into LVRM benchmark, right, which involves a lot of advanced tasks compared to image captioning and VQA, such as object recognition, localization, OCR, visual description, visual knowledge reasoning, right? So this kind of outperformed the Lava 1.5 with Vicuna 13B and EMI2 and Llama 33B by significant margin. So it kind of outperformed both. And comparisons with IDFX instruction tuned on Llama 65. So CogVLM scores exceeds by 19.3, 23, 20 on Seed Bench, Bench, and Lava Bench, respectively. So that we can observe from here, actually. The table would be much more clear, right? You can see CogVLM chat is almost superior to other works, right? So even Lava 1.5 that which I mentioned, right? There are these a lot of models are even bigger as well, right? So Llama 33B, Emu to chart. So yeah, here Vicuna 7B is the language model, but here is the 13B model. So on LVLM benchmarks also clearly shows that the CogVLM is showing a superior performance. That's what the table refers to. So another one is a visual grounding task. So here also there are various benchmarking data sets like RefCoco, RefCoco plus, RefCoco G. So on all these data sets, right? So it kind of on visual grounding data task. So CogVLM is kind of shown superior benchmark performance that one can see here. And generalist, so these are the generalist models like CogVLM grounding is clearly superior. These are the specialists. Like specialists means they're meant for only that task. So, but still, we can see that actually on all these benchmarks. So clearly, it is showing superior performance. So CogVLM is showing superior performance. So